All right, class. Welcome to lesson 10.1.2, which continues our study of circles, looking specifically at angles created within circles and the arcs. So this lesson gives some new vocabulary. It re-explains what we mean by an arc. It brings central angles into the context of a circle. It talks about arc length. It talks about measures of arcs, inscribed angles, intercepted arcs. Those are all key vocabulary words that you'll want to pay attention to as you work this lesson. Um, we're given a real world application of how we can use some of the things like angle relationships from parallel lines and our knowledge of central angles and arcs to work with the circumference of the earth. And it actually gives us a situation where Eratosthenes, who was an ancient mathematician, was able to calculate the circumference of the earth just by knowing the distance between two cities. So 1013 is a really interesting problem. Make sure you make use of those diagrams that they've provided because those really will be helpful. After that, work closely to make sure you understand the relationship between central angles and inscribed angles and the arcs that they intercept. And then 1016 gives you a chance to practice using those concepts. So at this point, I'll turn it over to you guys. Remember that you have a clearly formatted answer key now that you can check your answers on as you go through. And then once you've completed the lesson, please pop back to this video and we'll go over some of the main ideas. All right, guys, good luck. And welcome back. Hopefully you're now back to the video because you've completed it and you're looking to make sure you've hit all the main ideas. So let's just talk through a few of these problems. So in 1013, we're given information all stemming from Eratosthenes and how he found the circumference of the earth. We're looking at the cities of Alexandria and Sine and told they're 500 miles apart. We can consider the sun's rays coming in to be parallel because of the distance the sun is from the earth. And then using that meter stick that they describe in part A, we know that we have a triangle created at Alexandria from the shadow that comes in. So we have a stick that is 1,000 millimeters long. We have a shadow that's 127 millimeters. And we're trying to find theta, which is the angle you can see drawn in the diagram of the triangle. So it's the angle opposite the shadow and adjacent to the stick. So since we know the opposite and adjacent sides, it sounds like we'll be using tangent or its inverse to calculate theta. So that's the approach you'll want to use there, is to use inverse tangent of the shadow length over the stick, and then you'll have that angle theta. Now because the sun's rays are parallel, knowing theta actually allows you to know the central angle that opens up to that arc between Alexandria and Sine, because that central angle and that angle theta you calculated are alternate interior angles due to those parallel lines, so you know that they're congruent. And that's how you can work with this problem to then have an angle measure, to know the arc measure, and know that that 500 miles makes up just that small portion of the whole circumference. 1014, make sure we're comfortable with a central angle being an angle created from the center point of a circle when we open up to an intercepted arc on the outside. And it turns out that the central angle will have the same measure as the arc that it opens up to, so both can be described in degrees. The arc length is different than its measure. The length will actually be given in units like inches or centimeters, and it'll be an actual distance along that circumference. The real important new idea comes in problem 10-15, where we're given inscribed angles. And I know you don't have tracing paper, but you were asked to compare the measures of 3 inscribed angles that were all opening up to the same intercepted arc. Hopefully you noticed that they all had the same measure. Regardless of where they opened from, they end up having the same angle measure. When you compare them to a central angle opening to the same arc, it turns out that the central angle is actually twice as large as that inscribed angle, as long as they open to the same arc. That's important information, and that allows us to work with a variety of different measurements and travel between arc measurements, central angles, and inscribed angles, and make some comparisons. And that was what was done in 1016. 1016, the answers can all be found in the answer key, but you should have been using relationships to get central angles from arc measures or do the opposite. And once you had a central angle or an arc measure, you could always cut it in half to find the inscribed angle measure. So those were the processes that you were using. Part C, realize that if you have a 90-degree angle opening up to an arc, you're opening up to a 180-degree measure, which is going to end up meaning that you're opening up to a chord that's a diameter and half of the circle. So really make a note of that. Please use the answer key for reference, and if you still have questions after working through this lesson, be sure to take advantage of office hours from 9 to 11 to ask those questions, and we'll get you answers promptly. Remember, as part of the assignment, you do need to do the review and preview problems. These you can do all. There aren't any things related to constructions here. So go ahead, do that, and then submit it like you've been doing on Google Classroom, and let me know if you have any questions. All right, good luck.